Grade 7. I want to look at percentages. Well, they're called percents. That sounds weird, so I'm not going to say it. Little introduction here. Let's see what there is to see in grade 7. If I remember that a percentage is just not anything really new. It's just a fraction standardized to a denominator of 100. So do I have 100 little parts here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So this fraction is already over 100. Well, that's pretty easy. Over 100 because I have my whole square broken up into 100 equal pieces. How many do I select? That's 10 and 10 and 1, 2, 3, 4, 5, 6, 7. So that's 27. So that is a very simple introduction for a fraction over the denominator of 100. We take this and we move 1 0 up there, 1 0 up there, and stretch the 1 and make it diagonal. And there's our percentage sign, sort of. Because it's always over 100, we don't have to say a fraction every time. We can just focus on the numerator, which is the only thing that really changes. Here again, we have 100 as our denominator. What do we have here? 10, 28. Oh, that's pretty simple. So we can introduce our percentage concept as just a fraction again. Ooh, this one's different. Now we have a different fraction. Let's see. How many pieces do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And I'm selecting 2 of them. So now equivalent fractions as an introduction comes into play. I want to rewrite this fraction to a 100 denominator. I'm going to do that by multiplying both sides by 10, and therefore I get 20 over 100, and therefore the percentage is 20% of the selected portion. Now we can also streamline this to a little bit more of a shortcut where we can take the fraction and multiply it by 100, and then we'll get just the numerator of that fraction, but that's also all we care about for our percentage. So that's another way of doing it when the denominator doesn't scale that nicely to our 100. Maybe they give me something like that, maybe not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. This time I have 7 tenths as my fraction. If we want the percentage, which is the numerator, we can multiply by 100. And because the 10 is very easy to work with, we get 70, and so 70%. So I'm pretty sure at grade 7, we're not dealing with messy denominators in our original fraction, but you can multiply any fraction by 100. If it's a little messy, maybe eventually calculator is quite handy for that when I'm working with decimals and things like that. So the percentage concept, it's really just a standardized fraction. People make it sound as if it's much fancier than it is. It is not fancy.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
Let's try number 2. See how we progress from that basic concept. Well, maybe just the flipped version, or noticing that I can write my fractions, my percentages in different ways as a decimal, for example. So that one is just 7/10, making that a percentage. We've now seen multiply that by 100, and we very easily get our 70%. Now there's other ways to see this as well. You can also look at the 0.7 as 0.70, which means already 70 hundredths, and that gives you your numerator, which is your percentage. So decimals are actually quite convenient in that if I look at the first 2 decimal places, that gives me the standardized fraction already, and I don't have to do much. How do I write 6/10? See, they keep the denominator very simple. There's no need to make it complicated. Multiply it by 100. Hopefully by now, that should be super comfortable as a 60. How do you write 10% as a decimal? Ooh, so the other way around. So if I think about my decimal places, those first 2 count the hundredths. 10% is the same as 10, that percentage over 100. It's just a standardized fraction. And so that'll be 0.10 or just 0.1. You don't have to write the 0, but I'm going to. 0.10. So decimals are really super handy. Super handy. So I can flip, and I want to be comfortable flipping back and forth to any of these. That's 90/100. That's 0.90. These are all just the same thing, different visual representations of the exact same thing. They want the fraction. I don't have to simplify that fraction. I'm not going to. That's not part of the question. I don't care. I don't need to simplify everything at all times. So there's more to practice, but we get the idea. Okay, so that went up a little bit to start to be comfortable with viewing or flipping back and forth between fraction, decimal, percentage. It's all the same thing. And that, a huge benefit is to be able to compare these very conveniently. Because a percentage is this standardized fraction, it's much easier to compare, because when I'm comparing fractions, I want that denominator to be the same, to be absolutely sure that I can compare them. Then it's just a comparison of the integers in the numerator. So making everything a percentage is just another way of having a common denominator. It's just a very specific common denominator. So my first goal, to be absolutely sure, as I build a number sense, I can see, well, okay, 3/5 is being compared to 90%, which is 90/100, which is, I can simplify as 9/10, which is very close to 10/10, and 3/5 is far away from 5/5. So I do feel that 3/5 is less than 9/10, but in some cases, maybe I'm still not sure. I'm relying on my number sense, and that can be good enough if the gap is big enough between these, and one's obviously less than the other. However, what I could do is turn this into a percentage by multiplying by 100. Then I get 300/5, because 100 is just 100/1, which means I multiply the top, multiply the bottom. This is a very simple division. This is equivalent to 300 divided by 5, which I can look at 30 divided by 5, which is 6, and then attach the 0 at the end. The zeros help a lot. So it's not going to be that simple for any fraction here, but I can always do it. So that means this guy is 60%. So now I'm comparing the percentages, which is just the fractions with the same denominator, and it's an integer comparison, which is much, much easier. So standardizing it to a percentage makes the comparison of the quantities or the proportions very easy, and as suspected, the first one is indeed less. So standardizing makes everything easier. I don't even look at fractions. Fractions are scary and more complicated, and there's such a variety of fractions I could be working with. Percentages standardize it completely. So I just want to make sure, well, now I have my strategy where I can turn everything into percentages, and then the comparison is super easy. How do I do that? Take the fraction, multiply by 100. And in this case, I will get 100 over 4, which is the same as division. And that is 25. You can do your long division. Totally up to you how much you need to get to do to get to that 25, that answer. And so I see this is just 25%. So they are exactly the same. The more I see it, the more these little fractions become familiar and easier to work with, and I get a sense for percentages and their fraction equivalents, just like anything else. Familiarity and number sense does eventually kick in. So here, they're not the same format, but as we've seen before, the 0.53 is just 53 hundredths, which means it's 53% because it is standardized over 100 already. There's the 1, there's the 0, 0, 100. And so I'm comparing the same format very easily, same denominator, percentage, and the first one is less, of course.